Welcome everyone. Nice and bright and early this morning. I was a very good boy. I went back to my hotel nice and early last night just for you guys. Can't promise that for the rest of the week, but okay. I work for Oracle, so I put this at the front of all my slide decks. Most of what I'll be talking about today is available in open source, but it does get distributed with Oracle products, so I'm not committing to any release timelines on anything. Very non-committal today. So my name is Doug Clark. I am the Director of Product Management. I have a couple of different areas of responsibility at Oracle. Primarily, I look after the TopLink product line, the persistence pieces that feed into WebLogic and Glassfish. I'm the co-lead of the EclipseLink project, which is mostly what I'll be talking about today. And recently, I became the product manager for all the avatar stuff you've been hearing about in the Java 1 keynote. And that. I have some other sessions on that later this week. So today what I want to do is I have a lot of material. So we're going to see how this goes. I tried something a little different and reordered everything and tried to jam my 2.5-hour workshop into a 50-minute. But there's a lot of interesting stuff we've been working on for the last couple of years that I want to make sure people are aware of, and really explain how we see the persistent space evolving and give you some insights into where it's headed. So I'll try to be as quick as I can on the background material. So in the persistent space, our primary data source is relational. We deal with object-relational mapping. We are the reference implementation of the Java Persistence API, JPA. We've also done a lot of work in the recent years expanding what our persistence engine can do. So we've added a JAXB implementation to do XML binding. And then a couple years ago, we added a feature called Database Web Services, which was really focused on auto-generating a JAX WS-based web service. So that's kind of where we started from. And then today, what I'd like to do is walk you through some of the features we've added above this core persistence piece, and how it, every feature we add is based on conversations I have with people, customer visits, dealing with consultants, trying to figure out what you need next in your applications and try to deliver more, so each of your custom applications you have to code and maintain less. That's what I see my job as. So on the standard side, obviously we're very involved in standardizing persistence. We have JPA 2.0, which we're the reference implementation of. We implement JAXB 2.2. We are the reference implementation of SDO 2.1.1. And that's the last time I'll mention SDO this week, but I like to bring it up once. But some of the stuff we've been doing recently is we've expanded to add JSON binding support. A feature I call dynamic JPA, which gives you a lot of flexibility in how your models can be defined and evolve. Multi-tenant support or tenant isolation, different strategies for running in a software as a service environment with a shared database schema. I'll walk through some of those. And then we have a feature that kind of brings all of that together with Restful JPA. And that's some of the pretty exciting stuff we're doing. And it leads into thin server architecture, HTML5, JavaScript clients, and I'll hopefully have time to show some demos there. And then we've also introduced NoSQL support. So a similar object-relational JPA style binding, but to data stored in a NoSQL database. Looking forward beyond what we're doing today, we have the JPA 2.1 spec on the horizon. There was a number of talks this week on JPA 2.1, so I'm not going to touch that material. If you're interested in that, come by the booth and we can walk you through what's in that. We're going to standardize our JSON binding work. We're going to figure out what kind of standards people want around NoSQL in the Java persistence space. Right now it's kind of a maturing space. And then I also have some interesting stuff related to Java persistence in a JavaScript and Node environment, server-side JavaScript dealing with persistence. That's pretty interesting. And that I'm going to leave till my 5:30 BOF today. Okay, so the EclipseLink project that I co-lead has several key components: JPA, Moxie, which is our XML and JSON binding solution, and database web services. Our goal is to provide a common persistence engine that you can use in your applications, no matter where your data is stored, and no matter what kind of container environment you want to run in. Obviously, we're tightly coupled with the Java EE container, but we run quite nicely in Java SE, and we run out of the box as an OSGI bundle with special support for bytecode weaving in an OSGI container. So we're pretty unique in that space too. So pretty much anywhere you want to run your code, anywhere you want to store your data, and help you with the flexibility of doing the mapping. On the tooling side, we're an Eclipse project, so we're distributed through Eclipse and included in the Eclipse IDE. We are a key component of, obviously, Oracle TopLink. The product I run at Oracle basically redistributes EclipseLink and adds a little bit. We're shipped out of the box in WebLogic, Glassfish, and then there's some other open source projects out there that have started picking up the EclipseLink and distributing it. And that's far from complete, but that's some of the nicer pictures I could find. So I want to start with JSON binding. Obviously, with the growing use of REST and HTML5 JavaScript style clients, being able to work with JSON is very important. So what we've done is taken our JAXB implementation with its XML binding support and extended it so that with a given Moxie context, I could go to XML or JSON using the same mapping. And it's really flexible because I can actually, using the same configuration and the same running service, get my data in whichever format I want. So there is no standard in this space. A lot of the solutions you'll find out there actually translate from an object form into XML and then use a string-based conversion routine to go from XML to JSON. What we're doing is we're actually using a mapping engine to get the values directly out of your business objects and put them directly into a JSON structure. So it's a lot faster, it's a lot less memory intensive. On the standard side, our goal is to take what we've learned about JAXB, apply it into the JSON space and standardize this piece. So there's already a JSR filed for JSON-P, which is the parsing, which is comparable to the JAXB, the parsing side of XML. And then we're about to file the JSON-B spec. So it'll have a lot of capabilities very similar to JAXB, but just be JSON focused. So here we take a simple class. Right now we're just using JAXB annotations. I annotate my class, and then I can easily marshal using the same runtime artifacts to XML or JSON. And I dropped a code sample in here to show you how easy it is. What we did was we extended the marshaller and unmarshaller just to make use of a media type property very similar to how JAXRS works. So if you're actually using this inside of a JAXRS service, you take the media type requested, pass it to the marshaller, and it automatically gives you your objects back in that format. So that second line is the important one. The next one just really deals with how the root level element is spelled out or whether it's embedded. So when we started dealing with REST and XML binding and JSON binding in a environment with JPA entities, we ran into some problems. The JAXB specification is really focused on how do I get objects in and out of XML. The JPA specification is focused on how do I deal with relational databases, queries, foreign keys, primary keys. And then, these two specs never really sat down and sorted out their differences. So we ran into some problems. In JPA, you end up with a lot of cyclic references, bidirectional relationships based on foreign keys. There's some composite key classes. And then every persistence provider does some form of bytecode manipulation to be able to augment the state of the class to get better performance. You generally don't see it, but inside your classes, when you load it up in a JPA application, if you looked at it in a debugger, you'll see a lot of extra properties that you never wrote. we put them in there through the bytecode weaving instrumentation capabilities. But the problem is, if you add additional state to a class and then ask any reflection-based API to interrogate that class and do something with it, you're going to have problems. Some of those problems are very simple ones. Like if I put an additional state attribute on there, JAXB will automatically go through and put that in my XML. Say, you know, that was an easy one. When we bytecode weave the attribute, we add transient to it. But some of the more complex pieces are dealing with some of our relationships and some of the ways we deal with how we bytecode weave those. So starting out with a simple relationship, I have a project class project that has a collection of employee members, and the employee has a single project. So that's a very simple one-to-many, many-to-one return, very common in every JPA application. The problem is when you take that relationship and you convert it into XML, you end up with a infinite loop. You know, you have a couple of choices. Second here. Did you stop working for me? There we go. So we can strip out the relationship information and just marshal the core structure of that employee. But the problem is when you go to bring it back in, now I've lost information. So I need to have knowledge when I'm dealing with JPA entities going in and out of XML or JSON about these relationships and what they mean and how I want them rendered. So what we had to do was add some additional metadata to our mapping world. So here, an employee has a project, and I mark that as an inverse reference. So now the meta model knows when I'm reading this out, just the containment within the project of an employee, I can populate the other side. So really, I'm just telling the mapping engine which side I care about when you're creating the XML. So if you just took JAXB, the reference implementation, out of the box, your only way to make this work is to go in and break relationships in your object model. So basically, tear down your JPA mappings to make it work in XML. And nobody does that. So what everyone ends up doing is they end up making multiple domain model structures. And they write all this code to copy objects, their data values from the JPA entities into something that's JAXB friendly. And what we're trying to do is just deal with that JAXB JPA fidelity with a couple of simple configurations. So with that setting, we can store the values. My employee still looks the same as it does before, but when I build it back up, I can reconstitute all the relationships. So that was just one example. There's other challenges dealing with foreign key relationships within objects, large documents, how you reuse pieces. There's a whole set of functionality. If you Google EclipseLink JAXB, our chief architect, he blogs, I think, hourly. But the number of examples, I've got to the point now where I don't have to remember anything. I just Google it and all my examples come up. So Blaze Dawn, he publishes all kinds of stuff on all the features in this area. Okay, so that's kind of the introduction to our JSON binding. I'm slowly building to how all these pieces fit together. Another one that I was very involved with is a feature called Dynamic JPA. Obviously, sitting within Oracle and dealing with relational databases, I have a lot of customers who are other Oracle software groups. And one of the things we've discovered is a lot of the features they offer, like the BIPL solution and the SOA infrastructure, lets you go in and configure how you pull data out of the database and expose it to a web service. Well, they don't want to be code generating all these JPA entities, compiling, packaging, and deploying when there's no actual application logic. So what they wanted was a solution that let you use standard JPA without any Java classes. So what we ended up doing was we have a two-part solution in this space. We call it Dynamic JPA because there's no .java, we don't generate any source, there's no .class files, there's nothing packaged, it's all declarative JPA usage through a feature we call virtual entities and attribute accessors. And we're heavily using ASM bytecode weaving for this as well. The second piece is dealing with extensible entities, and I'll show some more on that. But on the dynamic side, here's a simple mapping for an address class. It looks like a standard ORM XML file. I have an address. The only difference is in standard JPA I define my access to be property or field for how the reflection engine talks to my class. Well, there is no class. So we added a new access type called virtual. And the only pieces you need to make this work is we need to know it's a virtual class. And since there's nothing to interrogate the class to get back its type, you have to tell us what the types are. So in here, my address ID is an int. I have a city, country, and postal code that are strings. But for the most part, it looks like standard ORM code with these small additions. And what happens at runtime is we actually bootstrap. Using ASM, we create this address class, and then we can do full standard JPA, full meta model, JPQL, even criteria queries, talking to the database. So if you have a situation where you don't know what the end domain model is or the relational structure a given application component is going to deal with, I can still build service modules that can be configured dynamically at runtime. The second piece of this is a little more common, and we've been dealing this. I've been working on TopLink now for a little over 15 years, and this problem has always come up. I write an application. I have all my attributes. They map to certain pieces in the database, but certain types of applications need to be more flexible. What they want to do is they want to allow you to configure additional properties that I can use later on post-deployment. So historically, what people would do is they would have a class that has a map of additional attributes. And in JPA, I can actually map that to a secondary table of key value pairs. The problem is it's not very efficient. Every time I want to read an employee, I have to read all of its key value extensions. So what we did in a couple of releases ago was added explicit support to let an entity type be extensible in the same row. And then you have a couple of options on the database side. You could have predefined flex columns, like reserved, unused columns that you later on define their use. Or some more adventurous customers are using schema gen at runtime to alter tables in a running database system. I have yet to meet the DBA who likes that idea. So for the most part, we call this kind of flex columns. You have a set of columns at design time that you say, I don't know what the end user is going to need, so I'm going to put these flex columns in. And then during the lifetime of the application, I can define through metadata what those columns are used for and get full JPA support. So here I have a player. His static attributes are ID, first name, last name, which are mapped as standard pieces. And then I have these additional flex columns that I'm going to define later. To make my class extensible, I need to say that I have virtual access methods, which says by default I have this get set pair that deal with the attributes in that map. I use field access by default, so I need to mark that as transient, so JPA doesn't pick that up as a special attribute and give me a blob column for it. So I need the get method here and the set. If I don't like those method names, there is additional settings in virtual access methods. I could use get, put, whatever I want. So those ones there. Then the next thing is, how do I define what these extended attributes are? So again, here is a snippet of an EclipseLink ORM XML file for the class player. And here I state the additional attributes. So I'm going to store penalty minutes and position, they're virtual, and I give the types. Now I can do this and package that up with my application, and it runs quite nicely. The other piece we've added is the support for pulling your additional metadata from an external source. So I could build an application, I could make it extensible, and then I can build a server admin repository where I can go in and configure these extended attributes. And every time the persistence unit gets rebooted, it will make a call to that service, pull this additional metadata, and augment the static metadata. And if all goes well, I can show you what that looks like at runtime. So again, it's the virtual access and the attribute type that I need to provide. Okay, the third piece to my puzzle is dealing with multi-tenancy or cloud-based deployments. I tend to focus on calling it tenant isolation much more than multi-tenancy. If you're going to a lot of the cloud talks here, when we as Oracle generally talk about multi-tenancy, we're talking about you as a consumer, that we want to keep your application isolated from anybody else who runs in our cloud. We want to keep your data isolated from everyone else. I'm not breaking any of those rules here. I do have a growing group of customers who want to build software as a service application. They want to build a hosted system where they can provision and deal with multiple tenants, and within their data set, they want to store it in a couple of different relational strategies. And it really comes down to how I want to share or have a dedicated database schema, table space, and then how my runtime architecture works. Whether I want to have a dedicated application per tenant or a shared application per tenant. So if you look at the dedicated, this is kind of the most common thing people have today. They build an application, it talks to a given data source, it has a database, it's completely isolated. If I want to deal with a second tenant, I would customize that application and deploy it again. That's fine. We've added support in all of these areas. So in the dedicated, I can actually customize and augment dynamically my metadata without changing the application. So I could deploy the application and have it pull additional metadata to talk to a different data source. The stuff I'm going to show in my demo is really dealing with some of the shared database and shared application space, where I have a single application that can host requests for multiple tenants. They can be stored each in their own database, schema, table space, however you want to isolate your data. Or what some of my customers are doing is they want to actually store it in the same database and stripe that data. So each database row is tagged with the tenant it belongs to, and then all the SQL to access it is augmented to do that tenant comparison. Okay, so in the dedicated space, everyone has a unique container. You can do full caching because you're in your own space. Everybody has a unique set of tables. There is no common storage. The only thing you must do is make sure it's deployed uniquely and has its own dedicated data source configured. Some of the more interesting ones is when you end up with a shared application, and when you come in the front door of the application, you have to indicate which tenant you are. It can all run in the same space with the same code. So this lets me scale up the number of tenants without having to redeploy a new application each time. So if you think about a multi-tenant application that has many small tenants, like I have one customer who does task management, and the number of active users they have is very small. So deploying a whole new WebLogic instance and dedicated application instance with a dedicated database is just too expensive. So what they do is they have this hosted environment where they still, depending on what the customer wants as far as data isolation, they can run in this mode with a shared application infrastructure, or they can start looking at shared database. So what we introduced last release was a multi-tenant annotation that basically describes how a given entity is stored in the database alongside other tenants' data. So the first thing we introduced was this default annotation, which is our single table, and it means the rows for multiple tenants are stored in the same physical table. So, it depends on your application how comfortable you are with this. We introduced the feature because customers wanted it. But the other piece that rolled out of it is we always had VPD support to do a database isolation of data using virtual private database and Oracle's label security support. So it was really easy for us just to piggyback on that existing functionality and add this VPD level. Now when I come in the front door, I specify my tenant. The VPD context on the database is set with the right credentials, and I can only read my data. So instead of doing SQL augmentation, the database is restricting my view of the table. So that's a lot more secure, and more DBAs tend to like that one better. Up here, I can't do native SQL support because I can't ensure that the SQL string follows my multi-tenant rules. But in the VPD world, since they're actually augmenting the SQL going to the JDBC driver, you have full access. It looks like a real database. The database just only shows you what you need. Okay. Tenant custom. Okay, I'll keep going on this. So the tenant strategies, as I mentioned, we added multi-tenant, which is the single table together. We have multi-tenant with VPD, which is basically just the single table, and we have this flag to whether or not we include the additional criteria. You do have to pass through the identifier and clear identifier. We look after that for you, but you need to map your tenant ID into the database credentials. And then, of course, you have to configure your database. So we've augmented our schema generation. So if you're running in this mode, we'll actually generate all the Oracle SQL necessary to set up VPD for you. That was a great feature because I can never remember that stuff. And then that was our first release with this multi-tenant. Then we added in the next release table per tenant. So now when I connect to the database, I can actually specify that each tenant has its own given database table by name, or I can actually dedicate a schema per tenant. So again, our goal is to give you whatever flexibility you want for how you want to isolate your data. So a couple of code samples here. There's a standard class in my sports demo. I have a player with a bunch of static attributes, and on the far right-hand side, I have this league attribute. So I can always support this in my application. If I wanted to custom code my application to isolate data by this column, I would just have to manually add that to all my queries. Always add the league that I'm looking for. What we're doing is making that a little more transparent for you. So here I say I'm going to use multi-tenant, which is a single table, common storage for all my tenants. My discriminator, to indicate very much like inheritance, which tenant it is, I have a property called league ID, and the column name, I just say which one it is. So now I don't have to map that into my object. Just every time I go to talk to this class, I need to specify a league ID property in order for it to talk to the database. And then on the VPD side, it's the exact same relational structure. Of course, the database has to be pre-set up. I just tell it I'm going to use a multi-tenant with VPD, and then that league ID property is used in the context value that it's passed into the database to set the VPD state. And last but not least, our new one, table per tenant. Here, I'm using a strategy by schema. So I have a schema for my high-tech hockey league with a player and my soccer league. So they each end up in their own schema with the same table name. I can also do prefix, postfix on the table name if I like to keep it in the same schema and just have it customized by name. Of course, in this world, I need to generate new tables for every tenant I provision. A couple of runtime architectures around this. One of the things that quickly comes up when you start looking at a shared application supporting requests for multiple tenants is dealing with caching and security of data. So if I'm dealing with a shared database, I can't read a row, convert it into an object, and put it into a shared cache, and then have another tenant show up and accidentally access data from another tenant. So out of the box, when you enable this, we turn off the shared cache. And of course, all our caching is configured by type. So, you might have some tables that are not multi-tenant and some that are. We just turn off the caching for the multi-tenant tables. So that each one of these requests coming in through its own entity manager, it runs a query, creates some objects, populates them. It's running in its own context with its own tenant identifier set on it. If I connect and I don't provide that tenant identifier to the entity manager, it will throw an error when I try to hit one of those tables. So this is what we do out of the box. There is the ability to turn on that cache, but we disable it by default to make sure that we've protected you as much as we could. Then we have some of the other strategies. Here I have 3 different threads coming in. 2 of them on the left are tenant number 1, and the one on the right is tenant number 2. So now what I've done is I'm spinning up a different entity manager factory. That's kind of the singleton in your application. Generally, you have one of those in your whole application, but in this multi-tenant world where I'm dealing with different tenant data sets, we now have added support where I can easily spin up an entity manager factory per tenant. Now within a given application, I need to look at the reasonable behavior I expect. If I have a limited set of tenants, tens, hundreds of tenants, it might be reasonable to create a new entity manager factory in every single application instance. If I have an unbounded set of tenants, this becomes a huge memory hog. So it really needs to fit in your world. So if you have a large number or a dynamic tenant base, you probably want to turn off caching and limit it. But some customers have asked us for the ability to have caching per tenant, and that requires having a whole entity manager with a backing session and its cache and its own data source access and connection pools. Okay, well, I'm making good time today. So what we've talked about is having a JSON support within my persistence framework. We've looked at dynamic persistence for how I can build models on the fly or make my models extensible. There is support for pulling metadata in from a running service so my applications become much more dynamic in their metadata. And then we looked at some of the multi-tenancy. So the last feature that we added, so last year at Java 1 we announced this project Avatar. And depending on which talk you go to this week, you'll get a lot of different definitions of what that means. I'll tell you what it means to me. It was kind of an overriding effort to address how Java EE developers can deal with HTML5 and JavaScript. So under that, we have a bunch of different areas that we looked into. So we've added WebSocket support. We have a proposed standard for WebSockets, server-sent events. JAXRS is revving, obviously, to support these clients, a nice REST interface. And then on the infrastructure side, we've done a couple things in toppling. But what came out of this was, how do I take an existing Java EE resource and easily build one of these thin clients? So what we did is we introduced something called JPA-RS, kind of playing off the JAXRS, which is support for exposing a JPA persistence unit over REST without having to write any code. And I'll explain what that means. For those of you who haven't done a lot with REST, obviously representational state, wow. JAXRS is the standard. There's two versions. The 2.0 is in progress right now, and it looks pretty impressive. I think they're going to wrap up very soon or freeze it as they work towards their new implementation. And what it really focuses on is, how do I programmatically set up my services within a Java EE container? So I have some code samples here. So if I take an invoice service that is able to read an invoice and return it to me, so here I've mocked out the example. I make it a stateless session bean. I drop some JPA code in here to find the given invoice. Obviously, my application never fails, so I don't need any error checking whatsoever. To make it a JAXRS service, you have to give it a path, which is basically the URI root within your application namespace for how it talks to this being over REST. And then I expose different operations. So within REST, I can do gets, puts, posts, deletes. So here we're going to do a get. And within my path, I'm going to say that after invoice, the next element is going to be the ID. That ID gets passed into my read method. Through this additional annotation, I tell the engine, get the ID off the URI and pass it into my method, and then I can run my code. And then as far as data format, I have to say which kind of data structures I'm bringing back, generally XML or JSON. There's obviously a number of other ones, but for my purposes today, those are the most important pieces. So what I end up with, if I send a get operation to my machine on whatever port, the application context for the the root URI for the application, and then I go /invoice and /for. What the JAXRS engine does is takes that information, translates it down, and says, okay, I have a bean that looks for invoice with a get operation that takes the next element of the URL and treats it as the ID, and I pass it in. So the JAXRS engine is all about doing that translation for you, and it does it very well. So what we end up with is we have a client application making REST calls over HTTP to my Java EE server, where I've exposed some set of session beans through a REST API. And then for our purposes, we're getting that data out of the database with JDBC using our JPA layer. So what you get at runtime, and this is, obviously doing all this JSON and XML binding, we started playing around a couple of years ago with how to best use our stuff within a REST interface. So with the JAXRS layer, typically we use Jersey here. I end up with a number of these session beans exposing services that I want to get to over REST. So when I make a request, like the one I showed you, that invoice request to get invoice number 4, the JAXRS layer does the translation and says, okay, you actually want to talk to the invoice bean, and we're going to pass number 4 in there. Then within my own custom code that I have to write in every single session bean method that I expose, I have to look up the persistence unit, create whatever kind of query or operation I need to do through JPA, talk to the persistence unit, run my query, it talks to the database and gets me back my data in object form, and then I need to return it. But that's a lot of code. Now for every persistence operation that I want to expose, I have to write one of these custom service methods. So what we did was introduce this other layer called JPA-RS, or RESTful JPA, which automates the exposure of a persistence unit. I don't have to do anything. When I enable JPA-RS, it will take all my persistence units, expose all the available operations, automate the binding to XML and JSON of all my entities. Of course, I can, go in and limit it and apply security policies for who's allowed to do this. But out of the box, I can just turn this on and I get full access. So now my get comes in, JAXRS hands it off to the JPA-RS layer. Now I have this additional root in my URI. The persistence unit name is the next piece, accounting. I want to talk to the invoice and do a given operation. The JPA-RS layer looks up the right persistence unit, converts all the input parameters that we need to run the operation, executes it through the persistence unit, gets back the result, and automates the return of that result to the client in the format they requested. So it's really about simplifying development. What we do is we've built a web fragment that you just drop into any Java EE application that has a persistence unit, and it will automatically spin up this REST interface. Obviously, we're tightly coupled to EclipseLink JPA, and we rely on Jersey for our REST interface. We've recently made some enhancements to make that portable. It should be completely standardized across any JAXRS implementation. What you get is all the functionality of your JPA persistence unit, whatever kind of caching, multi-node configuration, database, virtual private database, whatever other features of your backing store, and we get it out to you. Some of the unique features we added beyond that is obviously we've taken our dynamic persistence, so I can actually spin up a JPA-RS RESTful interface to my database using dynamic persistence and have no code whatsoever. I take a couple of standard persistence XML, our extended ORM XML, put it in a WAR file, deploy it, and I have REST access to my database. So you can use it both with an existing Java EE application or for one of these dynamic persistence units. And that's where we're starting to build out our tooling, where we can do it for you on the fly. Okay, so I see some people out there who are obviously interested in the NoSQL support based on their t-shirts. But I'm going to skip over to one of my demos. Okay, so we'll see how my application wants to run. Me and my computer have been having issues this week. So what I've built is a simple, somewhat simple demo application. And this is hosted on the EclipseLink project. It has its own Git repository. And what it does is it makes use of the multi-tenant capabilities, both with single table and table per tenant support. That actually loaded. And it makes use of JPA REST to expose that over REST. And we've also included this extensible entity support. So it's a little confusing because I jammed a lot of features in there, but I was having fun. And I run a lot of sports leagues at home, so I was working towards something I might be able to use. So what I end up with here is a very simple multi-tenant application. So on the home page, instead of logging in, I just have you pick which tenant you're interested in. And when you go in, it does some simple style sheet stuff. I am not a web developer. This is as fancy as I get. I was pretty impressed. I got to admit. I won't tell you the number of people who had to do the graphics and stuff for me. But so here I have my little soccer league. It has two divisions, my under 6 and under 8. If I go in here, I can see all the information. I can see my Bears team, and here's all the people. First name, last name. And since I'm dealing with little kids and snacks after soccer, I was curious what their food allergies might be. So that's a very simple application. If I go back up to the front, now I go into my, I believe this one, my kids' football league. So now I have the first name, last name, the position, their weight, and height. So what I've done here is I've actually taken the player class and make it extensible, which in itself isn't all that magical. But over in my admin app, so I have two running apps here in my Glassfish instance. In my admin app, I can actually customize and provision new tenants, and they become instantly available in my, my sports portal. So if I go in here to the soccer league, I got to get a big stick-em note. Doug, please refresh your application before you start clicking on things. Yeah. I don't know what the timeout is set on my app server. I think I'm good for about 8 seconds. So here in my admin console, I can actually look at the sports league. You know, I have a logo, a name. How do I want to do my tenant isolation? This one is set to row. And then down here, I'm tracking allergies. So if I decided that I wanted to also track shoe size, for whatever reason, I store that in the metadata database. I come back up. I come back in. This time I want to look at the sports team again. Oh, things did not work today. Okay, but I'll show you how it wires together. My admin app is actually running there, and it exposes a set of REST interfaces. So in here, it actually returns this. So this is my extended definition. You'll see I have divisions, teams, and players. They're all single table tenant isolation with the discriminator. And then down here on the player, the one I've made extensible, I have allergies and shoe size. So in the admin application, I go in and modify this, and it stores it however it wants to store its metadata. But then it makes this available. Now the running application, whenever it boots up a persistence unit of this type, it's configured to make a request to the admin server for the extended attributes. So if I refresh the metadata in that application, and restart it, it'll come up and it'll then expose these. Now in my JSF front end, I do a little work with the JPA2 meta model to actually walk through the meta model and see what the attributes are, and that's how I customize the columns. There's not a whole lot of black magic in there. So that gives me my extensible application. So, and then if we look, I'll quickly flip back over here to the console. Yes. So as I was walking through that application, when I made a request on the first page, it stored my tenant ID for me. If I had a more secure application, I would log in and it would, verify passwords and then cache within my session state on the web server who my tenant is. And then every time I talk to JPA, I pass that tenant information into the persistence context, and it makes use of it. So here I was using single table, and you'll see that all of my queries are actually augmented to have the league ID checked. So when I wrote those queries, they have no league knowledge. Just through the multi-tenant annotation and me specifying the property, all my SQL to that type is customized. I believe if I go back here and look at the football league, wow, we're fast today. Okay, this one seems to be running. Nope. So if I go back and look at the SQL now, this one is using a this is using table per tenant. So now when I log in and say I'm using the kids football league, unlike the soccer league, which is in the shared striped database table, this one actually spins up and uses its own dedicated table. And in my admin app, all I had to do was indicate that, if my admin app came back up, that I'm storing things in a table level. And if I'd spec schema level, it would have just looked in a different schema. So that all works pretty nicely. So the other piece that I wanted to show you that we've done on this application is I dropped the JPA RESTful capability into this app, and now I can come in here through my test client, my REST test client, and I want to do a quick run through. So if I ask for JSON, and let's see if I can get the right one. No, which localhost, my sports. Oh yeah. Get. Okay. That application is not behaving properly. Let's redeploy it. Okay, so if I talk to the application at the root level persistence, I can go in here, I do a get, I have to specify whether I want XML or JSON, and what we've done is we built out a metadata API as well. One of the tricks when we're trying to build these rich clients is what are the URLs available and what are their data formats that it returns. So in addition to just returning the data for your operations, we also added a whole metadata API. And as I navigate through this, assuming it wants to behave, make sure this one works first. Yeah, so there's my list of divisions, but I could also go through and say, okay, and this is really just exposing JPA standard metadata over JSON. So the URL I hit there was, I want to see the My Sports, the Ottawa Soccer League tenants metadata, and it says, okay, well I have 4 different types, user, division, player. And it was pretty nice. We decided to actually give you the URLs. And there's my metadata for a player. It's got ID, allergies, emails, first name, last name, user ID, version, and then some different links down here for queries that you might want to run. So that works nicely. I can change the type to be XML, and I get XML back. And really all we're doing is passing the media type through the JAXRS layer into our marshaller. So that gives me that piece. So then what the goal here is in this whole thin server architecture world exposing JPA over REST was what can we do? I'm not sure how well this is going to work. So right here we've built out a pure JavaScript HTML5 application that is completely client-side using the exact same services that I exposed. So one of our JavaScript gurus whipped this up for me. It took him about 20 minutes, and I'm leveraging my exposed JPA artifact without having to build a new custom client. The next piece we did was the JavaFX guys took that same hosted service and they whipped up a JavaFX client running on my machine. And again, it's making the same REST calls. And this one is actually using EclipseLink in JavaFX to do all the unmarshalling on the client side. So using the same soccer league, I can walk through and he can see all the attributes of the players. So that was pretty neat. I'm not a big JavaFX expert, so I was happy to be able to expose my stuff. Then he took that same one and installed it on my oldest ever iPad. This is my Finger of God demo. And again, this is hosted with JavaFX running on top of iOS 6 in development mode. And it's the same hosted service. So the whole point now is I can take my JPA work, expose it over REST really easily. Like I just dropped this web fragment into my packaged WAR file or EAR file, redeploy it, and I have this REST interface, and then I can go build whatever kind of client solution I want completely independent of that. So if I have an existing Java server faces back end, I'm doing whatever kind of server-side rendering of the client, and then I want to move into this world, we tried to make it as easy as possible. Okay, so that kind of pulls together all of our JSON, our dynamic, our multi-tenancy, and exposes it to this thin server architecture, JavaScript, HTML5 world. Some of the other areas we're working on is NoSQL support, and this is the last one I'll touch on today. Now this is not standard JPA. I need to make that very clear. To be compliant JPA provider, it's very clear right now the JPA standard is coupled to relational. But what we did is we stepped outside the JPA spec and tried to build a JPA style access because we wanted to get it out there and get some feedback. Obviously every NoSQL database has a Java interface of some form that works quite nicely, and this style of access is not going to be applicable to everyone. Our goal was to deal with the same problem space we've always dealt with this binding to my domain model and using my domain model in my application space and then storing the data into the NoSQL store. So obviously if you're going to use a large Hadoop data store storing documents, it probably doesn't fit well into an object relational or object NoSQL kind of solution. But this is really to get some work out there and get some feedback and see what people are looking for and where we should be looking at standardizing this in the Java EE space. So obviously there is no standards right now. We have to do a custom integration with each solution. We've shipped 2 solutions, one with Mongo and one with Oracle NoSQL. A couple flavors in there with the Berkeley and the new NoSQL API on top of that. When you run queries, depending on the backing store, you'll always have different levels of functionality. So some data stores we're only going to be able to do primary key gets. Some we can do a little more rich criteria-based queries. When we sit on top of coherence, not truly what everyone would think of as a NoSQL store, but we can do a similar operation. We take your JPA query, we parse it down into our own expression graph, and we generate coherence filters. So we're applying that same logic in what we're doing here with NoSQL. And we're just trying to offer whatever capabilities they have and expose it up through a JPA-style interface. It has some custom annotations. It does some subset support of JPQL. As I mentioned, we have 2 databases. We're looking at additional ones now, always looking for feedback on what people like this and what additional data stores they're interested in. And then we also have some interesting capability to mix relational and non-relational persistence, which I think is going to be more of these hybrid data store solutions. So we have another talk a little later today, a couple hours from now, called Polyglot Persistence. And in there, they're going to deal with bringing together some of the Mongo store, relational store, and wrapping it all up in one facade with multiple persistence units, or what we call composite persistence units, talking to these data stores, and provide the JPA programmer a consistent API. So here's what it basically looks like now. These examples are taken off the EclipseLink wiki. So I state how I want, what style of NoSQL access, and then within the mappings, I need to provide some additional field information for how it's stored. And we have a lot of leeway in where we're headed in this space, obviously with the ability to bind into and out of JSON. JSON storage databases might look a little different to us. Again, this is not an effort to standardize. This is an effort to engage and learn. So if you're interested in a Java API that can kind of bridge across multiple data sources, we'd like you to try this out and give us some feedback. Okay. So just to kind of wrap up where we are and kind of where we're headed. So EclipseLink 2.0, which was the RI for JPA 2.0, came out in 2009. As an Eclipse project, we tend to ship on the annual Eclipse release train. So usually we're busy coming into June. We introduced, upgraded to JAXB 2.2. The JPA fidelity features, that's how JPA entities work better with JAXB. And we added dynamic JPA. In 2.1, which was the Eclipse Helios release, we extended our queries. We can embed more database functions. We can do treat as for casting within JPQL statements. Some new batching operations to give more flexibility. Attribute group is really great for defining partial entity graphs, how you load, how you fetch, merge them. We introduced our own OXM mapping file. And we did the same thing we did for JPA with dynamic Moxie. So now I can have a complete metadata-driven solution that does both JPA and the XML JSON side. 2.3, which shipped in 11, introduced our first tenant isolation, multi-tenant with single table, the extensible entities. External metadata is the feature that will pull the additional mapping information from another source at runtime. Being composite persistence units, dealing with multiple data stores. Data partitioning, probably more commonly known as sharding, being able to partition your data across multiple tables to deal with some scalability issues. And then 2.4, our last one to ship, was the JSON binding support. We introduced our first release of JPARS, table per tenant. We enhanced our schema generation to do alter schema. When you start looking at all those extended attributes, it became clear that people who do want to customize their database, we've always been able to drop tables and create tables. In a production environment, dropping a table and creating a new table sounds nice, but losing all the data, not so good. So we finally got around to alter schema, where we can add columns without having to drop the whole database to do it. So, lots of people have their own DBAs who do all their own schema management, but there's lots of smaller shops who rely on the JPA persistence provider to generate these scripts for them or to do it directly on their database. And 2.4 introduced that initial NoSQL. So where we're headed now, obviously we've introduced this REST interface. We want to continue to enhance that. There's some great work coming out in our next release for better handling relationships within those REST objects. And one of my new projects is dealing with server-side JavaScript. So we have a talk this afternoon looking at the new Nashorn JavaScript engine that's coming in SE8 and this prototype node implementation we have running on it. And then in there we have varying degrees of support for JPA within a JavaScript node application. So if you're interested in where we're headed with that stuff, I believe my BOF is at 5:30 today, somewhere. That's so my 4 o'clock problem. So that's what we got. How did I do on time? We're done. So I ran out of time without questions. I'm happy to stay around and ask questions. I don't have anywhere to be immediately. I will be up at the Java 1 demo grounds for most of the day. If you want to come by there, walk through one of these demos, talk more in depth. Again, we're always looking for feedback, and you guys are really in charge of guiding us in what we need to do next. Thank you.